In the previous module, we saw that when we employ this production function and use the direct profit maximization method, we can derive these input demand functions and this output supply function. We'll now use the two-step profit maximization method to see if we arrive at the same answers. In the two-step method, we think about costs first and then bring in revenues. So in the first step, we ask, what's the minimum cost, where the cost is our labor cost plus the cost of capital, that we incur if we choose the right level of labor and capital, and we try to reach a certain level of output x, where x has to result from this production function. So it's equal to 21 times L to the 1/3, K to the 1/3. We can solve that problem by setting up the Lagrangian, which first has the thing we're trying to minimize, the costs WL plus RK, plus lambda times the constraint with all the terms collected to one side, x minus 21 L to the 1/3, K to the 1/3. Then we take the partial derivative with respect to the things we're choosing, so with respect to L and with respect to K. And those will be set to 0. So the partial with respect to L will give us a W minus 1/3 times 21 is 7, so minus 7 times lambda L to the minus 2/3 K to the 1/3. That's equal to 0. And with respect to K, we get an R minus 7 lambda L to the 1/3 K to the minus 2/3. And that's equal to 0. We'll then take these two equations and move the negative terms to the other side. So that gives us W is equal to 7 times lambda L to the minus 2/3 K to the 1/3. And R is equal to 7 times lambda L to the 1/3 K to the minus 2/3. Now to get rid of the lambda, we just divide the two equations by each other. And the 7's will cancel, and the lambda will cancel. And we can simplify this. L to the minus 2/3 divided by L to the 1/3, we simply subtract the exponent, so we get a minus 2/3 minus 1/3, which will give us a minus 1, so L at the bottom. 1/3 minus a negative 2/3 will just give us a 1, so K will be at the top. We can then solve that for one of these. We can solve it for K. So K is equal to W over R times L. Now that we have K as just a function of the input prices and labor, we can substitute that back into our third equation, the constraint up here, to solve for just one of the two inputs. So if we do that, we say x is equal to 21 L to the 1/3, and then K to the 1/3, but we're going to use this to stand in for K. So W over R times L to the 1/3. Now we can simplify that to 21 L to the 1/3 times L to the 1/3 will be L to the 2/3 times W over R to the 1/3. We want to have an expression that tells us how much labor we're going to need to produce a certain level of output. So we're going to solve for L. So we want L on one side and everything else on the other side. So L to the 2/3 is equal to x divided by 21 times the inverse of this, because we're dividing both sides. So R over W to the 1/3. And then to get just L, we're going to take both sides to the 3/2. So that'll give us L on this side On this side we'll have x divided by 21 to the 3/2 times r over w. If we take 1/3 to the 3/2, we multiply the 3/2 times the 1/3, so that gives us just a 1/2. Now we have an expression that tells us for any level of output and any input prices how much labor we're going to need if we try to produce that level of output in the least cost way. Finally, we can come up with the same expression for K by just substituting this L into this expression. So K is equal to W over R times L, but we're going to use this. So times X over 21 to the 3/2 times R over W to the 1/2. And simplifying that, we still have our X over 21 to the 3/2. We have a W to the 1 divided by W to the 1/2, which gives us a W to the 1/2. We have an R to the 1 at the bottom and R to the 1/2 at the top. When we divide that, we get an R to the 1/2 on the bottom. So we now have an expression for capital that tells us how much capital we're going to need if we want to reach a certain level of output X for any wage and rental rate. So this is our second, what we call conditional input demand. Conditional on wanting to produce the output level X, it tells us the least cost way of producing that level by telling us how much labor and capital we should use. So these are conditional input demands. Input demands are a function of output, the thing we're trying to reach, as a function of just the input prices. That's what happens at the tangencies of these isocosts to isoquants along the cost minimizing ray. So we can now use these two to figure out what the costs of the firm will be for different levels of output. So the cost, and we call it C, is equal to wage times labor, and this tells me how much labor I'm going to use. So X over 21 to the 3/2 times R over W to the 1/2. That's my labor cost, plus the cost of capital is R times how much capital we're going to use. So X over 21 to the 3/2 times W over R to the 1/2. We can simplify that. W to the 1 divided by W to the 1/2 will just give us a W to the 1/2. And we have an R to the 1/2, so we get WR to the 1/2. And we still have X over 21 to the 3/2. Here we have an R to the 1 divided by R to the 1/2, so that'll give us an R to the 1/2. We have a W to the 1/2, so again we'll have a WR to the 1/2. And we still have that X over 21 to the 3/2. So we have exactly the same two terms, so that's just equal to 2 times X over 21 to the 3/2 times WR to the 1/2. Now we have a function that tells us for any level of output how much it's going to cost to produce that if we produce it in the least cost way, depending on what the wage and the rental rate is, our cost function. We're done with the first step of the two-step profit maximization method. The second step says that if you're going to produce where price is equal to marginal cost. So far, price hasn't entered into this. Price doesn't matter for costs, the price of the output, but now we want to figure out what's the right level of output to produce. So we have to figure out what the marginal cost is. The marginal cost is just the derivative of the cost function with respect to x. So we need to take the derivative of this with respect to x. So we have a 3/2 times 2, which will give us 3. We have that 21 to the 3/2 on the bottom, times x, subtract 1 from the exponent, so x to the 1/2, times WR to the 1/2. So we're differentiating with respect to x, so everything else remains the same. So now we have a marginal cost curve. This is the marginal cost we're going to incur for any output level x, given the wage and the rental rate. And in two-step profit maximization, in that second step, we say we need to set that marginal cost equal to price. That'll tell us how much we should produce. So we're going to set price equal to 3 divided by 21 to the 3/2 times x to the 1/2 times WR to the 1/2. Now to figure out how much we should produce, we have to get the x to be by itself on one side. So x to the 1/2 is equal to, we have to divide by 3 and multiply it by the 21 to the 3/2. So we get 21 to the 3/2 divided by 3 times p, and we have to divide both sides by WR to the 1/2. And now we just have to square both sides. So we'll put that over here. We get x is equal to 21 to the 3/2 squared will just be 21 to the 3rd. 3 squared will be 9. P squared. And WR to the 1/2 squared will just be WR. So what we have is an equation just like this. P squared, WR. And this, if you multiply it out, is just equal to 1029. So now that we've set price equal to marginal cost, we figured out that x is going to have to be this. We figured out the supply function that tells us for any output price and any input prices, how much of the good x we're going to produce. That's the supply function, the same supply function we got when we did direct profit maximization. Finally, we could take that x and substitute in for the x in the conditional input demands. So if you put this x into here and you simplify it, you'll end up getting this. And if you put this x in here and simplify it, you'll get this. So it'll also give us the actual input demands, not just the conditional input demands, once we figured out what the x is that we actually want to produce. So either way, we end up with exactly the same three functions. The input demand functions that tell us for any set of input and output prices how much we're going to demand of labor and capital, and how much we're going to produce, how much we're going to supply for any output price and set of input prices.